Hello dear boys, hope all of you are well. In our previous class we have known about the three coefficient of expansion of heat. In our today's class, we will discuss about the relation among the three coefficients. Relation among the three coefficients. So we have two relation. One is relation between relation between linear and area coefficient, and the second is relation between linear and volume coefficient. One is relation between linear and area coefficient, and the second part is relation between linear and volume coefficient. Okay, so our first part is relation between linear and area coefficient. Relation between area and linear and area coefficient. So from area coefficient we know that A2 equal to A1 plus alpha A1 T2 minus T1. This is our equation 1. So as a area we know that it is the multiplication of two lengths. Area is the multiplication of two lengths. So for area we can write L2. For A2 we can write L2 square. Again for L2 we know that L1 plus alpha. For area this is beta. So here L2 equal to L1 plus alpha L1 T2 minus T1. We know that for linear expansion we get L2 equal to L1 plus alpha L1 into T2 minus T1. By putting this we can write it as L1 plus alpha L1 T2 minus T1 whole square. So expansion it by using our formula A plus B whole square, our well-known formula A plus B whole square. We know that A square plus twice A into B plus B square. So we can write L square plus twice alpha here L1 and L1 multiplication. So we can write L1 square T2 minus T1 plus alpha square L1 square T2 minus T1 whole square. Here the value of, we know that in our previous class we shown that the coefficient, the value of coefficient is very smaller. The value of coefficient is very smaller, and we know that if we square, if we square the lower value, then it becomes more smaller. It becomes more smaller. So we can write if the value of, we know that the value of alpha is very small, so the value of alpha square will be more smaller, so we can avoid the term, alpha square. So by avoiding alpha square term, we can write that value of alpha is very small, so value of alpha square will be more smaller. So avoiding the term alpha square, we can write, avoiding this part, we can write A2 equal to L1 square plus twice alpha L1 square T2 minus T1. Again, we know that the area is the multiplication of two lengths, so we get L1 square as A1. So putting this into this equation, we get A1 plus twice alpha A1 T2 minus T1. So we can denote it as equation 2. Our first equation was A2 equal to A1 plus twice beta A1 T2 minus T1. This is our first equation. So comparing equation 1 and 2, we can write A1 plus beta A1 T2 minus T1 equal to A1 plus twice alpha A1 T2 minus T1. Okay, so we can, by calculating, we can write beta A1 T2 minus T1 equal to twice alpha A1 T2 minus T1. Now divided this equation by A1 into T2 minus T1, therefore we get beta equal to twice alpha. This is our relation between linear and area coefficient. This is beta equal to twice alpha. Beta equal to twice alpha. This is our relation between linear and area coefficient. Okay. Okay. Now we will discuss about our second part, relation between linear and volume coefficient. Okay. Relation between linear and volume coefficient. We know that we denoted our linear coefficient as alpha and volume coefficient as gamma. So we need to calculate the relation between alpha and gamma. So in our from our volume expansion, we can write V2 equal to V1 plus gamma V1 T2 minus T1. We can denote it as equation 1. Okay. Again, we know that volume is the three times multiplication of length. Volume is the 3 times multiplication of length. Okay. Volume is the multiplication of 3 length. Volume is the multiplication of 3 length. So from volume V2 we can write L2 cube. Again, from our linear expansion we get L2 equal to L1 plus alpha L1 T2 minus T1. So we can write L1 plus alpha L1 T2 minus T1 whole cube. Here we will use A plus B whole cube formula. So we know that A plus B whole cube formula is A cube plus thrice A square into B plus thrice A B square plus B cube. Using this formula we can write here L cube L1 cube plus 3 into A square into B, 3AB. So 3A square into B. So here 3 into L square into alpha L1 T2 minus T1. So we can write 3 alpha L1 cube T2 minus T1. Again here we can write 3 alpha square L1 cube T2 minus T1 and plus we can write B cube as alpha cube L1 cube T2 minus T1. Okay, so in our previous term we said that the term alpha is very small. So the term alpha square and alpha cube will be very smaller. So avoiding alpha square and alpha cube term we get or we can write B2 as L1 cube plus thrice alpha L1 cube T2 minus T1. Okay. Again we know that volume is the multiplication of 3 length. So we can write L1 cube equal to V1. L1 cube equal to V1. So we get V1 plus thrice alpha V1 T2 minus T1. So this is our V2, this is our equation number 2, and our equation number 1 is V1 plus gamma V1 T2 minus T1, equation number 1. So comparing equation 1 and 2, we get V1 plus gamma V1 T2 minus T1 equal to V1 plus thrice alpha V1 into T2 minus T1. Okay, so we can write or gamma V1 T2 minus T1 equal to thrice alpha V1 T2 minus T1. So divided this equation by V1 into T2 minus T1, we get our final relation gamma equal to thrice alpha. So this is the relation between linear coefficient and volume coefficient. So we get linear coefficient relation between linear coefficient and volume coefficient is gamma equal to thrice alpha. So now we can get our relation, our term relation among three coefficients. From our number 1 relation, we get beta equal to twice alpha, and from second part we get gamma equal to thrice alpha. So multiplying equation 1 by 3 and equation 2 by 2, we denote it as equation 1 and equation 2. So we can write equation 1 into 3 and equation 2 by 2, we can write thrice beta equal to 6 alpha and twice gamma equal to 6 alpha. Okay, so we can denote it as equation 3 and equation 4. So comparing equation 3 and equation 4, comparing equation 3 and 4, comparing equation 3 and 4, we can write 6 alpha equal to 6 alpha equal to thrice beta equal to twice gamma. 6 alpha equal to thrice beta equal to twice gamma. Okay, so So this is our relation. This is the relation. This is our final relation. So in comparing equation 3 and 4, we get 6 alpha, or we can write 6 alpha equal to 3 beta equal to 2 gamma, twice gamma. So this is our final relation among these three coefficients. This is our final relation among these three coefficients. So all of this for today. So thank you. Bye.